Welcome to the video lecture for Unit 1, Module 1.2.1. In this one, we're going to cover the parathyroid glands. Most of the video lectures that are in Module 1.2 are going to be relatively short. We're just going to cover a lot of the different glands that are in the endocrine system, but I wanted to separate them out just so that nobody got confused. Don't forget about the learning objectives here. Remember, that's how I create quiz and test questions. So let's jump into this one. So the four parathyroid glands, which are embedded in the posterior surface of the thyroid gland, secrete parathyroid hormone in order to elevate blood calcium levels. There are normally two pairs of parathyroid glands that are embedded in the posterior surface of the thyroid gland. A dense capsule surrounding each parathyroid gland separates it from the cells of the thyroid gland. Altogether, the four parathyroid glands weigh just a mere 1.6 grams or so in an adult. The histological appearance of a single parathyroid gland is shown here in the figure to the right. The parathyroid glands have at least two cell populations. The parathyroid, or the chief cells, produce parathyroid hormone, and the functions of other cells, called oxyphils, are generally unknown to us at the moment. Like the C cells of the thyroid gland, the parathyroid cells monitor the circulation concentration of calcium ions. When the calcium concentration of the blood falls below normal, the parathyroid cells secrete parathyroid hormone, or PTH, which is also known as parathormone. The net result of PTH secretion is an increase in calcium concentrations in body fluid. Parathyroid hormone has three major effects. One, it mobilizes calcium from the bone by affecting osteoblast and osteoclast activity. PTH stimulates osteoblasts to secrete a growth factor known as RANKL, or RANKL. Osteoclasts have no PTH receptors, but both precursor and mature osteoclasts have RANKL receptors. This growth factor results in an increase in osteoclasts and in osteoclast activity. With more active osteoclasts, the rate of mineral turnover and calcium release accelerate. As bone matrix erodes, blood calcium rises. 2, it enhances the reabsorption of calcium by the kidneys, reducing urinary loss. 3, it stimulates the formation and secretion of calcitriol by the kidneys. In general, the effects of calcitriol complement or enhance those in PTH, but calcitriol also enhances calcium and phosphate absorption in the digestive tract. Figure 18-13 that you see here to the right illustrates the role of calcitonin and PTH in regulating calcium concentrations, and it's likely that PTH, aided by calcitriol, is the primary regulator of circulating calcium ion concentrations in healthy adults. Information about the hormones of the thyroid gland and the parathyroid glands is summarized in Table 8-4 that you see here.